example 12.21. Right, I'll just repeat it again. So this is the polynomial, and in the question you're asked how many roots does it have, and it has, how many roots does it have? 3 roots. Right, so that was the first question. And in the second part 2 it said if x plus 2i is a root, you should automatically be able to find the next root, which is, change the sign here, 1 minus 2i. So we have the 2 complex roots, so the third root, we know there's 3 roots, has to be real. Third root is real. Now the next step is to find, you don't have to take it down if I'm going to record it, if you're going to, well, you can still take it down if you want. To find the third real root, this is the method for finding the third real root. I'll put it back in a second. So the complex roots are x plus 2i and x minus 2i. If I add those 2 roots together, I get 2. If I multiply those 2 roots together, I get the number 5. Now I need to form my quadratic equation. So I have z squared, a z, and a number. So 2 goes there, 5 goes here, plus, and a minus. Well, this has to divide evenly. This quadratic equation has to divide evenly into this. If that's a plus, it won't divide in. It won't divide in. You can try it yourself later if you like. So is that okay so far? Right, so now you need to divide it in. Three z cubed minus 5z squared plus 13z plus 5. And we're dividing by z squared minus 2z plus 5. Right, so z squared first of all. Do you want to watch this if you're not too familiar with it? Dividing by z squared. Are you watching? Right, so z squared into 3z cubed is 3z. Now multiplying, so 3z times z squared, 3z cubed, 3z times minus 2z, 6z squared, 3z times 5. Line across, change the sign of everything. So this will become minus, plus, minus. Those 2 cancel. Here you've got, what was that, 6 wasn't it? You have z squared and you've got minus 2z plus 5. See the minus here, 2z? So that divides in how many times? Once. Plus 1. So multiply 1 times all of this. Change the sign of everything. This is plus, becomes a minus. Alright. So this is, we've got 3z plus 1 is the factor. So 3z plus 1 divides evenly into this polynomial. So you've got to find the root, the third root. 3z plus 1 is equal to 0. 3z is equal to minus 1. Z is equal to minus a third. Alright, so you'll find, if you draw an Argand diagram, z is equal to minus a third, and the other 2 complex roots were 1 plus 2i, and the other one was 1 minus 2i. There were the three roots.